Today, I will be talking about the mean value theorem. But before we start with the equations, I will be first explaining what specifically mean value theorem means. Okay, so let's get started. The MVT, which is also known as Lagrange's mean value theorem. So LMVT, it provides a formal framework for a fairly intuitive statement relating change in a function to the behavior of its derivative. So overall, this theorem states that the derivative of a continuous and also differentiable function has to attain the function's average rate of change in a given interval. So overall, if the f is continuous on the closed interval of a and b, and also differentiable on the open interval of ab, then there exists a number c in ab. In other words, if a function has the same value at 2 points, then it must level somewhere between those points. By considering whether the function is increasing or decreasing immediately after the first point, it becomes clear that neither option can continue indefinitely if the function is to return to the same value. Therefore, there must be a local maximum or minimum before the next point occurs. Okay, now let's learn about the formula which is used over here. The MVT says that for a function that meets its conditions, at some point the tangent line has the same slope as the secant line between the ends. For this function, there are two values, c1 and c2, such that the tangent line to f at c1 and c2 has the same slope as the secant line. Now, let's take another example. As you see in here, in this picture, the straight line connecting to FA with FB is equal to the gradient line at one of the points between A and B. So in this example, the curve never dips below the line that is connecting between FA with FB. Now, let's suppose that the function is continuous and it's differentiable on an interval of AB. Then in here, there exists a number which we'll call it C. So such that the equation is this, which is the slope of line FB minus FA over B minus A. There's also another slope, which is y2 minus y1 over x2 minus x1. So the derivative at the point is the same thing as the slope of the tangent line at that point. So the theorem just says that there must be at least one point between A and B where the slope of the tangent line is the same as the slope of the secant line from A to B. Okay, let's now solve some problems to enlighten our memory and also to learn more about this topic. This is the first example for us to solve. So in here, they have given us the function and they ask us to find all the values along in the intervals of 1 and 5, and also the tangent line which is parallel to the secant line to the x's that they have given. So the first thing we know that with this kind of questions that we get, we have to always use the MVT theorem. So what we have to do right now is to plug the functions in them. So as we have the formula, which is FB minus FA all over B minus A, we know that always A is 1, which is given also, and the B is 5. So we're going to plug them in this function. So we get 5 over 5 minus 5 over 1 all over 5 minus 1. So now once we got this, we have to solve them. And once we solve it, we get an answer of 1 minus 5 all over 5 minus 1. So in this case, what we have to do is that we have to subtract them. So 1 minus 5 is negative 4, all over 5 minus 1 will be 4. And our final answer is going to be negative 1. Now we know that the f prime of c equals negative 1. And because this function satisfies the MVT theorem for the given interval, we know that there's at least one point in the interval that has a slope of negative 1. Now let's find out which point it is. So we're going to bring the function again right here, which is fx equals 5 over x. And this time we have to differentiate them by using the quotient rule. So we will write it as the following: f derivative of x equals with the quotient rule all over here, and we have to simplify them basically. And once we simplify them, we'll get an answer of -5 all over x squared. Now, we have to bring back our f prime of c, which we got, which was -1, and set equal to -1. And after that, what we have to do in the next step is that we have to solve for f prime x, which is -1. And once we did it, we have to use the radicals in order to throw out the x squared. And then finally, we get an answer of x equals plus or negative radical 5. And then now we can throw out negative radical 5 since it's not in our interval. So we get an answer of positive and negative square root of 5. Since the negative value is not in our interval, the answer is the square root of 5. Then we have to plug them back into our original equation to find out what the point is. So the f is going to be square root of 5 equals 5 over square root of 5, and that we get of square root of 5. So the points that we got is square root of 5 and square root of 5. This is basically an instantaneous rate of change. There are also some practical applications to this as well, and one of the applications is to find the instantaneous rate of change in here. So let's find out how to use the mean value theorem for this as well in here. This is the question that is given to us. Yet the MVT is not only used for these kind of examples. Now we are going to take a problem which we just worked over on it. Now, the first thing that we have to do is we need to use the times that the car passed by the radars as our endpoints. We can let A equal 0 since the car passed the radar, the first radar, at the time of t equals 0. For the other point, B, we can use 5 minutes, but we have to convert it into hours as the units are miles per hour. So overall what we get is t equals 5 minutes all over 60 seconds. And if we divide both of them, we get 1 over 12 hour. And then now we have to let the st represent the distance traveled by the car. So we have s0 equals 0. At the time that t equals 0, the car is at a position of 0 miles. And s1 all over 12, that equals to 6, at time t equal 1 over 12, is the car at a position of 6 miles. Now for the average velocity of the car over this 6 mile section of highway, we are going to use the MVT theorem, which is the mean value theorem. So the average velocity equals to FB minus FA all over B minus A. And by this, we are going to plug our answer, which we got lately, that was 1 over 12, into this. So as I explained, the S is going to be our B, which is 1 over 12, minus the A is 0. And then we're going to divide it by 1 over 12 again, minus 0, which we got as A and B. And then once we solve this, we get an answer of 6 minus 0 all over 1 over 12. And once we divide them, we get an answer of 72 miles per hour. So by using the MVT, we proved that at some point along the 6 miles stretch of highway, the car must have been going around 72 miles per hour, which is above this limit. Thank you.